These are two real-life applications of Calculus BC that were in this course. So the first one is parametric equations. Parametric equations are a really broad topic. The specific use of parametric equations that I'm going to talk about is comparing to and putting them together to see how they compare. So the system for parametric equations is shown as x of t, comma y of t, and it is found by plugging in your t value to get a coordinate. This isn't limited to this use. This is just the broad definition and use. It can be used to compare multiple functions that relate to time. This isn't only position. It can be other functions like I have an example on the next page. These can be used in many different fields of versatility because many different things have to do with time, like population size, maybe profits, number of items sold, stuff like that. So now on to the real life example. So this real life example is on the left. We can see the comparison of ice cream and temperature. On the right, we see amount of sunscreen sold and temperature. In the middle, we compare ice cream and sunscreen, and we get rid of the temperature or the t variable in these two equations when we combine them using the dy dx equals dx dt or dy dt over dx dt. So what's the use of this? Well, what we conclude from the graph is that as more sunscreen is sold, more ice cream is sold as well. So they have a direct relationship. So these equations can be used for many different uses, such as in businesses where you can relate two different time functions or two different functions with a similar variable, which was t in this equation, temperature. It can demonstrate the specifics of various relationships so entrepreneurs can optimize their businesses. So this can be used for example, if you have one graph which is profit over time, another graph which is maybe temperature over time, temperature throughout the year. If you have an ice cream business, then you can compare your profits versus the temperature. And it can be used to know when your customers are going to come and when you're making the most money. So on to position, velocity, and acceleration. This is the relationship between position, velocity, and acceleration used in integrals and derivatives. So position is obviously where the object is located, the distance or the coordinates. The velocity is the speed of the object at t. Acceleration is the change of speed of the object at t. And then here's just the relationship. Velocity is the derivative of position. Acceleration is the second derivative of position or the derivative of velocity. And vice versa for integrals, it goes the opposite way. So for example, velocity is the integral of acceleration and position is the integral of velocity. So these relate to any real-world problem where you have one measurement of position, velocity, or acceleration, and you want a different one. So you can take the integral or the derivative once or twice, and you get any of those. So for a real-life example, I have a sled manufacturer wants to know the maximum velocity and acceleration of their sled, but only have the position of the sled at any given time. Natural log of x plus e is the equation of the position of the sled. So here's the graph that shows it. So with this relationship, you could take the derivative once, and you get the velocity. And then with that velocity graph, you can see the maximum velocity, the maximum speed, the maximum, and then you can take the derivative one more time. You get the acceleration graph, and you can determine the maximum acceleration as well. So this information could be useful to the company, so they could make sure that this sled isn't going accelerating too fast or going too fast, I guess, or going too slow, so they could redesign it to improve their sales. So this relationship is important to a company. An engineer could use this relationship to calculate the velocity and acceleration to help the company out. This isn't limited to sleds. It could also be more useful for a car manufacturing business that wants to know the acceleration of their car or the max velocity of their car, so they can advertise this. So these two examples are very useful in various fields, from entrepreneurship to engineering, and can be very helpful to companies and different careers.